This is pre-AP calculus. We're in note 7.4. We are specifically looking at how can we use our calculator, excuse me, how can we use our calculator in order to make an equation given a list of ordered pairs? And that's called regression. Now, if those ordered pairs form something that resembles a line, it would be a linear regression. But we are talking about exponential functions, so it's an exponential function. So just to review with you how you do this on your calculator, and I assume you've done this before since you've had Algebra 2, you're going to hit the Stat button, and then you're going to choose, let's make this a button, then you're going to choose Edit, and then you're going to enter values, specifically X values, into L1, and enter Y values into L2. Does it have to be an L1 and L2? It does not. But that's what I'm going to do just to make sure that we're all on the same page, figuratively, and literally, page 16. I'm going to choose L1s and L2s. Then, once you got your list in there, it's a list of ordered pairs, you're going to choose Stat again, Stat button on the front of your calculator. Then you're going to choose Calculate, and then you're going to choose, I don't know why that arrow is there. Since we're doing exponentials, you're going to choose exponential regression. A regression is when the calculator, or you can do it by hand, but it takes hours, chooses a curve that best fits the data. So let's read this together, and then we will use our calculator to figure this out. A pharmacologist is testing a new antibiotic. At the beginning of the first day of the experiment, there were 2,500 bacteria in the culture dish. Now that is actually an ordered pair. That's the ordered pair 0, 2,500. That's pretty important. At the end of each day, the number of bacteria present in the dish was recorded in the table. So keep in mind, at the end of day 1, that's a second before the beginning of day 2. So this could be essentially be said at number 1 here is the beginning of the second day. Based upon your data in the table, is this an example of exponential growth or decay? So we are going to put this stuff into our calculator. I guess before we do that, I guess we can answer this question. As the days get bigger, notice how the number of bacteria are getting smaller. So the number of bacteria are decrease. Are they decreasing at an increasing rate or a decreasing rate? Decreasing at a decreasing rate. I believe we would find that to be true. Therefore, it's exponential decay. I mean, it's got to be exponential because we're told that it is. Alrighty, I am going to explain to you how to do regression on your calculator. This is an Algebra 2 skill, and you've likely done this before, but I'm going to refresh you on this. Specifically, we're looking at page 17 in our notes. There is a table of values there, starting from day 1 to going to day 6, and a number of bacteria present in a petri dish, culture dish, if you will. It also mentions in the problem at the beginning of the first day, that would be times 0, there are 2,500 bacteria. So if you go here and if you hit the Stat button, and then you choose to edit the list. I typed into L1 the X values from my table from days 0 to 6. I included the hidden ordered pair 0, 2500 because that was in the problem, wasn't in the table. And I put these different Y values here from the table as well. Now, since we're told this is exponential growth or decay, we are going to then go to our home screen. So hit second, quit. And now we're going to hit the stat button again. We are going to do a calculation. So push 1 to the right. We're going to choose exponential regression. Sorry for the shaky cam. Exponential is here at 0. So you hit enter. My X list was in L1, my Y list was in L2. If yours are different, you need to change it. Frequency list needs to be empty. When this is done, where do I want it to put the equation? I want it to put it into Y1. So if I hit alpha F4, I can choose Y1. Go down here and calculate, and it's going to use those points and give us the best exponential equation that would fit the data. So A to 3 decimal places is 2629.226. B to 3 decimal places is 0.838. Don't worry about R squared or R at this point. Notice if I go to my Y equals button, I told it to put the equation in here, and it did. If I go to my graph, I want to first set the window. My days went from 0 to 6, so it'll give me a little bit more room. I'm going to go -2 to 10. And my Y min was 800. I'm going to go down to 0 for that. And my Y max, my biggest number was 2157. I'll just go 3000 for giggles. Now, if I were to graph this, I'm getting closer, but I also want to turn my stat plot on. If I hit second stat plot, notice how it's off. It should normally be off, but I want to see the ordered pairs that I just put on here. So I'm going to change this to on. Scatter plot's the type. My X list was in L1, my Y list was in L2. If I now hit graph, I'm going to see those points, and then I see this curve. That curve isn't going to go through all the points. It never will. But there's a big explanation for this that takes a long time to explain. But in general, this is the curve that fits the data the best. So that's how you do a quadratic regression. Make sure when you're finished with this, go back to second stat plots and make sure you turn that plot off. Because if you don't, you're going to get to a point in the class where nothing's going to graph correctly. Won't graph at all, as a matter of fact. All right, now we're back from our calculator. Using the regression capabilities on your calculator, which we just did, find the function f of x equals a times b to the x that models the data in the table. So using 3 decimal places, we get that a is 2629.226, and that b is 838 thousandths to the x. How many bacteria will be present at the end of 10 days? Show your work. So this is f of 10. This is all the work we have to show for this. We're putting that into this function. And we will find that that is about 449.023. Word problem, want a sentence answer. After 10 days, about 449 bacteria will be in the culture. D, on what day of the experiment would the pharmacologist expect the number of bacteria in the culture to be below 100? Explain your reasoning. We should already have in Y1 this function. Just put it in there for you because we asked our calculator to. If you don't have it in there, put it in. Then you'd want to find you'd want to put into your calculator y2 as 100. So we got this curve that's coming down like this, and then we got this line, which is 100. We want to figure out where these two intersect each other. So you do second, calculate, intersect, first curve, yeah, second curve, sure, guess, you know it. We're looking for the x value. What we end up finding here with our calculator, that x is about 18.498. Now keep in mind, let's go back to the beginning here. The entire first day, at the beginning of the first day, is at 0. So that means any fraction of the first day, like 0.98, this is the first day. This 1 is at the end of the first day. So any 1 point somethings, that's going to be in the second day, because the first day is over, now we're in the second day. So that means this here, this is during day 19. Sentence answer, on the 19th day, the number of bacteria will be 100. Well, it says, let me rephrase that. On what day will the number be below 100? On the 19th day, the number of bacteria will be below 100. E, will the bacteria ever be completely gone from the culture? Explain why or why not using your knowledge of graphs of exponential functions. Well, this graph has a horizontal asymptote at 0. So technically speaking, mathematically, the culture would never get equal to 0 because it's a curve that's getting closer to it but never actually gets to it. But real life-wise, once the number of bacteria is less than a half, it basically means you don't have, you either have a bacteria or you don't. I guess probably you would say once it gets less than 1. But let's just go full math on this and not use common sense. So f of x's graph has a horizontal asymptote at y equals 0. Therefore, f of x, the number of bacteria, will never reach 0. So I guess technically if you got part of a bacteria in there, then maybe common sense wise says, yeah, it's still there. You know, it's a leg of a bacteria. All right, that concludes these notes. Thank you very much. You should practice some regressions.